Hello guys, welcome to our topic 1, that is Introduction to Java Programming. Basically, these are table content of what we expect in this document. One thing I'd like to mention is that in object-oriented programming, the language of choice that we're going to be using is Java. And Java is a high-level third-generation programming language, just like any other languages such as C, Fortran, C++, and so on. So those languages are basically high-level language. Now, we can use Java to write computer applications that play games, all sorts of applications that you can think of. Then Java has the capability to be able to do that. So compared to other programming languages, Java is most similar to C. And that's why you'll notice that if you've already done C programming, you'll notice that some of the concepts that we're going to be using are similar. Though we'll be programming in Java, but you'll begin to notice that some of those concepts we're using are a bit similar. Java compiler won't compile C code, and most large C programs need to be changed substantially before they can become Java programs. So you can't, just because we are saying that C programs, they look much more like Java programs, we can't just pick a C program and compile it on a Java compiler. So Java is related to C++ also, because C++ is an object-oriented programming language, and Java is also an object-oriented programming language. So the concept of object-oriented will be the same concept we're using in C++ will also be in Java programming. So this is basically just an introduction of what Java is all about, comparing it with other languages. Now, when you compile Java, basically what you get is a bytecode. It's nothing but an immediate representation of Java source code. Now, this bytecode is machine independent and is not completely a compiled code, but it's an immediate code. So it's a transformation from your source code to a machine independent code. So that's what Java bytecode is. Now we have programming primitives, that is primitive data types. Now these primitive data types, I know you've used them over and over and over in other programming languages. Here we basically talk like when you create a variable. A variable is a storage location for your programming. When you create that, you need to create a variable identifier, and to create a variable identifier, you need to state its type, and this is basically what we mean by primitive types or primitive data types. So in Java, we have about 7 of them that we're going to be using. Here we have byte, we have short, we have int, we have long, we have float, we have double, and we have char. So those are the 7 of them. Now remember, for each variables that you're going to be creating, or variable identifiers, there are rules that must be followed, and that's why now we talk of naming convention. So variables and variable methods, variables and methods should start with lowercase. We have an example given here of int age double amount. So as you can see, the amount and the age, they all begin with lowercase. After beginning with a lowercase alphabet or character, you can change to uppercase if so wish. Now the same applies also to methods. When you're naming methods, you begin with lowercase, and that's why we have this method here we are referring to as add. Add begins with lowercase a, and then we have dd, add. The dd can be in uppercase, but the a needs to be in lowercase. So that's basically just a naming convention that you can use. Now, if you want to mix lowercase and uppercase, that's what now we refer to as the camel case. So if we have more than one word making up a variable, then it is always important, it's always advisable that you join them together and make use of the camel case. A is an example. Student age, those are 2 different words, student and then we have age. But you don't write them separately. You put them together, and then what you do is that for the second word you begin with uppercase. Now that's a camel case style of coding. So these also you can apply it in every variable identifier that you're going to come up with, and can also be applied on methods. That's why you have public void add student. Now these are two different words, add and students. Now you are able to show distinction between the two by the uppercase S, but you must write it as one word. But the distinction comes in where we're going to have the uppercase for S. So that's a style of coding that you can use. We are referring to as camel case. The same applies also when you are naming variables that are too long, variable identifiers. Like here we have int and then number of student. You can see O and S begin in uppercase, in I begins with uppercase, and then class C begins with uppercase. That's another way of naming it. So one thing you must also consider is for class name should always start with uppercase, and so we are able to look at the code and we are able to tell clearly that these are class name. So we have public class, C begins with uppercase. That is, C for car begins in uppercase. So we can clearly look at it and tell that whatever comes after the class is the name of the class, and so the name of the class is car. You can type public, or you may not type it. If you do not type it, automatically after compilation it will be added. So any class that does not begin with public, and you go straight away and begin from class and then the name of the class, after compilation public will be added. Constants, when you are working with constants, we basically use all uppercase separated by underscore for multiple words. Here we have an example. This one doesn't have multiple words, but this is pi. Like example, if you are given an exercise or a problem where you're supposed to write a program that will compute the area of a circle, definitely we know pi is 3.14. Therefore, you don't need to keep repeating 3.14 in your code. So basically what you can do is just set pi, that is pi, as constant, so that whatever it is that you're going to use pi, it will substitute it with 3.14. Now, if you're going to make use of a constant that has more than one of those words, like number of class size, you can write it like that in uppercase, and then you join them using underscore, and then you can set the value. So whatever it is, whatever on your code that you're going to use number of class size, it will be substituted with 50. Now remember, we set them to be static because we want it to maintain that particular value all through, and therefore that's why we set it as static. Now let's see what else we've got here. Now, desirable features of Java. Number one, Java is platform independence. So number one, Java is platform independent. Java is most known for its platform independence nature. One can write a program in any environment and can be able to run it on different platform or hardware. So Java is compiled and run with JDK. JDK basically is Java Development Kit. So before you can start working with Java, or before you can install Java in your computer system, what I mean is, before you can install IDE for Java in your computer system, you need to install the JDK. So JDK is very important, and we also it comes with JRE, that is Java Runtime Environment. So the two of them work together. So JRE is what makes Java program run. This JRE can be different for different platforms, but Java code will run on each JRE. So there's no difference. The kind of output you're going to get is the same kind of output that we'll be able to get on another different computer system that is on a different platform, and that's why we say it's platform independent. Java is also secure, and you notice that it even comes with libraries that would even support cryptography, can allow you to write code that is much more secure. Java is also simple, just like you write programs using C, C++, and over time you kind of feel that they are simpler and they are easier to write. So the same is with Java. Java is created in such a way that you don't have to write a lot of code. Most of the code is in the libraries or classes that we do import. So all is left is for you to just write a minimum amount of code, and that makes it much more easier. It's also portable, and that is a big thing. Where we have platform independence, then it goes along with portability. So that's a big up for Java. It's robust. JVM is the root of Java. JVM is said to be the best virtual machine meant deal date, and that makes your code or the applications that you develop to be robust. They don't fail every now and then. So JVM enables a strong debugging and compilation capabilities that make Java an error-free and easy to detect errors. So any program that is devoid of errors, then we expect it to be much more stable, hence robust. Multi-threading is another one. It supports fully integrated multi-threaded environment. This feature makes the developers to utilize bandwidth and reduce idle time in idle CPU time. That is, it can be able to undertake different tasks at the same time, multiple tasks at the same time. Remember the key feature, we say that Java is object-oriented programming, and we make use of objects. Create a class, and then you create an object of that particular class. Now, let's look at attributes. Attributes basically a character of an object. For example, if you have a class named student, then we expect there to be attributes of this particular student, like registration number, name, gender, and so on. That's basically what we are talking about. So if you create an object, then it ought to have that. Here we have an example of a car may have attributes speed, direction, registration number, and so on. So a class itself would basically be more of a blueprint of an entity that you intend to collect data about. So the definition of object of the same abstract data type in Java class is basically the keyword used to define a new type. Then we look at dynamic binding, the identification at runtime of which version of method is being called. We have what we refer to as polymorphism. Polymorphism basically means having many forms. We are going to discuss and even write codes on polymorphism later on in our class. We have encapsulation. Encapsulation, the combining together of attributes and methods. That is to encapsulate it. It's to put it inside. That's basically what encapsulation means. Inside something where we cannot easily be able to access it, and therefore that code or that method would be encapsulated there. We have inheritance. If we can borrow some properties or some attributes from another class, then we can say we have inherited them. So the derivation of one class from another, so that the attributes and methods of one class are part of definition of another class, then that is the inheritance that we are talking about. And an interface behavior that a class exposes to outside world, it's the public face, the face of that particular class, which is the contract. A contract is more like saying, I will do this. So it is guaranteed that if you use an interface, then it defines clearly what exactly you're going to have to use for that particular class. It sets the limit of what you can do with it. So in Java, interface is also a keyword similar to class. However, a Java interface contains no implementation. Basically, you just write the code without the body part. Then you can fill up the codes later on when you make use of that particular interface. Polymorphism, remember we said polymorphism basically stands for many forms. It's from a Greek word. So generally the ability of different classes of object to respond to the same message in different ways, that's what we are referring to as polymorphism. So methods are used which have one name but different implementation. Like you can have a method for addition, you can call it add values, but it has two arguments within it or two parameters within it. Then you can have the same method add values having 3 parameters within it. So looking at them is the same method, but the moment you run this particular method, it has to be viewed differently, and that's where now the polymorphism concepts comes in. Primitive types, you've looked at them. We use them to create variable identifiers, and here we have example of int, float, double, char, then boolean. Now we have a simple example here of a code. Example 1, it begins from this page where we're saying we have package my OOP Mbuni. Now whenever you see package, just in your mind let it be that is a folder. So we expect our code to be inside folder my OOP Mbuni. Then we are importing. The reason why we import is so that the keywords that we're going to use in our programming can be recognized or they can be supported. Now here we are importing java.io dots and then everything that will be in that folder. So we're going to import that, though it is always specified that you be specific on what you're importing so that you can make the code much more efficient. Now here we have a simple class. Remember, we have just said that when you are talking of a class or when you are declaring a class, you're giving a class a name, it must always begin with uppercase. So that's why we have my simple class, and it begins with uppercase. And remember, we said this form is what referred to as the camel case, where you're going to join different words together to form one single word. But for you to be able to separate or to see distinction between the different words is that you begin by uppercase and then lowercase, uppercase, lowercase, and so on. So here we have our class, the first class. So we open with opening curly brace, and then we get into the main method, just like languages in C, C++, and so on. Whatever kind of applications that you're going to write using those languages, you must have the main method, because compilation always begins from the main method. Now in Java, these are we write the main method: public static void main, and then we have string, and then we have our arguments. Now this is the way it will always be, so it's not going to change. So you better memorize this line and make sure you understand it. So within the body of the main method, and this main method begins from where we have opening curly brace and it ends where we have the closing curly brace. So this particular main method here, it has this all we can find. This statement is all we can find in the body of this particular main method, and therefore we expect it to give an output that says I am a simple class in Java. So everything within quotes will always be output exactly as it is. So how do we output in Java? By simply typing system.out.print. It can be print, it can be print ln. Ln means basically you're going to output on the next line. So you can write a system.out.print, and you end it there, and you put your opening bracket and closing bracket and whatever you want to put within the quotes, or you can add the ln. It's all the same. So once you execute this statement, it's going to give you what? It's going to say I am a simple class in Java. Okay, now we can write this class using our favorite IDE. I basically like using Eclipse, and therefore once I've installed Eclipse, what I can do, I can click here if this is the first time you're working with it, or you can come to File and then New, you go to Java project, give your Java project a name, maybe my OOP class. Just click Finish. Don't need to create that. Once we have created that, once we have created the project, then right click on the project, then new, and then we say class. Now, remember we had a package name or the folder where our class is I think it was my OOP Mbuni. That is, if you wish to work with a package, you can get rid of the package if you don't wish to work with the package. But it's always good to work with a package. Now, the name of the class was my symbol class. There we go. Yeah, there it is. So we begin with the main method. We said it's public static void main. Then you're working with string there, and then we have that's opening curly brace there. The best thing about some of these IDEs, you open the curly brace, it gives you the closing curly brace so that you don't end up forgetting. So we want to print, and therefore a system dot out dot println. You can work with ln, and then we are saying it ought to output maybe something like I am a symbol class in Java, and then always don't forget to terminate there. Doesn't have any error, we save and then we execute. Let's see what you're going to get. There is an output. There is our output. I'm a symbol class in Java. There. Now, we have seen that one can work, and therefore let's proceed. Now, import. Import is very important. In Java, we need to import the required packages. By default, java.lang. The asterisk is imported. Imports are used to import classes into your classes that are not in the same package. Package, remember again when I mention package, just understand it's a folder. So for example, here, the top of Java source file may look like this. Here is an example, simple code that we have in here. Package com.deku.generics. So these are three folders. One folder is inside another folder inside another folder. So here we have import.util.arrayLists, import java.util.iterator, import java.util.list. And that's why I was saying it's always important to be specific exactly the kind of class that we want to import. If it is ArrayList class, be specific, mention it, rather than writing java.util.asterisk, because now it will import all classes that are in that particular folder, and we will not want that. That will make your program inefficient. So the above could have been written instead of, you can write it like this, but I'm saying it's not always good. Always be specific as shown in this code that is highlighted. Now, package is the folder. We've been mentioning package over and over. And what we can see here is that we have one folder inside another folder, and that is this folder is inside this folder, is inside this other folder. And that's how you create it. Basically, you'd want to be unique, and therefore you're going to be unique. Then use your company name if you have a company name. That way you are very unique. You're sure that nobody else is using the same kind of paths that you're using for the storage of your files. Now let's get to class. Since Java is purely object-oriented programming language, we cannot write a Java program without having at least one class. It won't work. You always must begin with a class. It must have a class. As you've seen in the previous code that we have just written, the main method must always be there, because execution always begins from the main. public static void main. So it's usually given as static because it doesn't, the main method doesn't need to be instantiated. Then we have this string part, which basically is a parameter within the main method. VM always looks for the main method with string type array as parameter, otherwise JVM cannot recognize the main method. So that main method must have this argument. And then obviously when you open a curly bracket, you must always close it. Here we have another example of code. Let's look at this code. Now you understand this is a folder. Import java.util scanner, public static calculator. The name of our class is calculator, and then we go straight to the main method. Will always be written as such. So we open our curly brace, and these are comment. These are how you write a comment. 2 backslashes. That means that area will be ignored by the compiler. Now we can use our primitive data type such as ints, and then we have what? We have variable identifier prod, fnum, snum. Then we can initialize them here. You can see there is initialization. Fnum is equals to 5, snum is equals to 10. Then we can make use of, we can do some calculation here where we're saying prod is equals to fnum multiplied by snum, and then eventually now we can make an output using println. So here we have the product of, this one will be substituted with 5, and snum substitute with 10 is, and then the answer of multiplication of 5 and 10, obviously that's 50, so prod will be 50. Now what you're seeing here, after the quotes we have a plus symbol, and then we have our variable identifier there, plus, and then words in quotes, plus, and then our variable identifier. What we are basically doing is that we are doing concatenations, referred to as concatenation. Now looking at this code, there was no need for us to do this importation here. We have an import where we are saying import what? Java util. So this line was not necessary because we did not make use of scanner class. Okay, let's do the calculator code. Basically, we just need to right click on our package, then new. This time we are selecting class, then it's a calculator. Okay, there it is. So let's get the main there. These are main function as it was in the example of the tutorials that we are looking at. So we need a closing curly brace there. Yeah, there it is. So remember we had said that this is basically just a comment, and then this we have declared prod, fnum, snum. Then fnum we have initialized them to, that is fnum is equals to 5, snum is equals to 10. So we do some kind of multiplication here. We first close that. Okay, so prod is basically for product. Yeah, it will hold the product of multiply the two values. So, and then we have a concatenation here. Let me just try to put the code together. There we have the product of, then plus is a concatenation, concatenating with fnum, and then concatenate again with snum, and then concatenate again with prod. So let's run this code. Let's save it and run it and see the kind of output that you're going to get. There it is. Product of 5 and 10 is 50. We can create some space here to make it, just to format the output so that we can get better outputs. Let's try it again. Yeah, there it is. The product of 5 and 10 is 50. But on the second code here, where we are trying to improve the code such that we are not initializing, but we are giving the user an opportunity to type the values via keyboard. So it's the same code. We've just changed the name of the class to the scanner input. Okay, now we go straight to the main method. Everything remains as it is. We declare our variable identifiers prod, fnum, and then we have snum. Now, because we have a scanner, now we have introduced that line, scanner. Now this scanner, this line, let me light it properly. So we have scanner input is equals to new scanner and then system.in. So if you look at this class, is the one that we have imported up here. So this class, we are creating an object of it using input. You can use anything here. You don't necessarily have to use input. You can say scanner X is equals to new scanner, or you can say scanner B, whatever it is that you want. But input helps us understand what it is that we want to do with it. So we want to use it for purpose of input, and therefore we can give an output that says enter first number. Then we would have our fnum. Remember, it's declared here is equals to then that object input dot next int, and this one now will allow a user to be able to type the value rather than have the value assigned. The same applies to the second one, enter second number, and then we have our snum is equals to input dot next int, and then we do have prod is equals to, just like in the previous code, fnum multiplied by snum, and then we can give the output the same way we had given in the previous code. And there we have improved this code by allowing a user to enter via keyboard, to enter the value rather than have the values assigned as shown here, where we have fnum is equals to 5, snum is equals to 10. That is assignment. But what we wanted is for the user to enter the data, to be able to enter this data rather than have it assigned. Okay, looking at example number 3, where we are making use of scanner, basically need to do an import there. Imports, then we import in java dot util dot, and then we're looking for the scanner class. Scanner here, scanner class. Yeah, we've got it. It's underlined in yellow because yes, we have imported, and then but we've not been able to use it. So what we're going to do right now is let's say system.out.println. You can say enter first value. Then now we get rid of that. Now what we can say is, before we can do that, okay, what we need to do here is do the create an object for our scanner. Can be input is equals to new scanner, then it's definitely going to be system system.in. So now we use these objects, the input dot, and we're working with integers, therefore it's next int. It's next int. There. Yeah. That's the only way we are going to have to enter that data. We can do likewise for the second one, enter second value. Second value. Now this one will be the snum. Snum, exactly as we declared it, and get rid of that. So If we run this, we expect it to work now without any issue at all. So let's try and run this code. Compile it. Yeah, it says enter first value here. First value, maybe we enter 24. Second value, we enter probably 30. And there, we get an output. It's now working. It's allowing the user to enter the data he or she wants to work with. We have another example here. This example is a program to calculate the area of a circle. So the name of the class is area of a circle. You can see we have the camel case style there in naming the class. Then we have set our constant pi is equals to 3.14. Then we have public static void main. I've told you that line remains as that. And then we have declared radius as double, and we have given it a value 7. See, since it is a double, when you just say 7, it will be 7.0 because you have said it's a double. The same applies to area. Now, we're saying area is equals to, they were saying area is equals to our constant pi multiplied by radius multiplied by radius. We know to calculate the area of a circle is pi r squared. So that's why we are doing that. And then we get the output of that particular area. We have another example here. Looking at this example, it's the same thing. What we're trying to do is that rather than assign radius 7, you want the user to type. And it comes here. This is where we are making the changes over here. The same code. Now we're saying we have declared radius equals, and we have assigned it as 0. Value 0. Then we have scanner input equals to new scanner. We cannot use this if we have not done the importation. So anytime you want to use scanner, you must import. So we come back here and say system.out.print enter radius of the circle. And then after saying enter radius of the circle, we're saying radius is equals to input.next double. Now the other one, remember we said next. There was a previous one that we said next int. So since we are working with double, it's next double. And it will allow user to enter the value. It will be picked as a double. Now area is equals to pi multiplied by radius multiplied by radius. That is pi r squared. And then we get the output there. As simple as that. So see you in the next class.